with the server loads that are required. Today's server does not look like yesterday's server. So let's talk a little bit about some of those differences. We need performance. This is the bottom line. We need high performance, 12,800 megabits per second, 2 million IOPS, 5 million PE cycles. And it all starts with this processor chip and its direct relationship using DDR to the actual DRAM. This is the highest performance area that you can get. Of course, it is the most costly as well, and it has one downside: data loss. Data loss when power goes out. And so now let's talk about kind of that next phase, which is DRAM plus NAND technology. So NAND provides us with other features. It's faster in spinning disk, limited endurance, and data retention occurs when we lose power loss. So we're keeping our data, but we're sacrificing some of our performance. Now put those two together and you have NVDIMM. This is the best of both of these worlds. It's going to give us the performance that we want with low latency and no data loss in the event of a power failure. So there are other storage mediums that we can look at as well here, hanging off of the CPU. NAND Flash is one of them that uses PCIX. And then we have a hybrid 3DX point that's coming out that's a PCIe and DDR. So that's a hybrid. And then, of course, we have the southbound hub here, for example, the PCH chip that then has and supports SATA to support and give us that SSD and disk. Of course, lower performance. So let's draw this up, erase this here, and let's go ahead and draw up kind of a summary of the highs and the lows. Let's put an arrow in here. So low latency, high endurance, higher bandwidth. You want to go with everything to the top of this picture, right? So the highest performance you're going to get is pure DRAM, but you're not going to get the protection that you need. So you're going to need, and that's where NVDIMM really comes in. So higher performance as you go up this scale in this model that we're looking here on the right, and lower cost, lower performance, more of a size more than speed is going to be at the bottom end here where you see the SATA connections to spinning disk and SSDs. So this is, in summary, this is kind of where technology is meeting together. We're bringing, for example, DRAM and NAND Flash, putting it together now, and it's been around for a while, in NVDIMM. This is coexists in a DDR3 slot with other memory inside of that slot, although we don't get into the details of exactly how NVDIMM works. Essentially, we're doing our reads and writes and taking advantage of that higher performance and the higher endurance on our DRAM, and we have a battery system or some sort of power system so that if, for example, we lose power, it immediately dumps DRAM right into NAND, which will then protect that data within seconds. This isn't convoluted with multiple systems. It's all built within this board here, this NVDIMM, and it will take and preserve anything in DRAM before all power gets lost to that server. Upon reboot, essentially the DRAM is checked for its state, and then it recovers itself from NAND if needed to bring it back up to speed. And we're talking within seconds here for all of this to occur. So pretty exciting stuff. This is the beginning, really, or the continuance of this merging of technology inside of our servers to give us higher performance.